Okay, this is a continuation of the lecture video for MAC1114 trigonometry. We're in section 8.2, law of sines, and we continue now with example 5. Okay, so in this problem, we are given two sides and an angle. Now let's see if it is the side-side angle, but if they're asking you questions are offering you answers where they're implying that it could be a single or two triangles or no triangle, it's because it's the side-side angle combination. But you need to know whether you're into that possible ambiguous case even when not prompted by answers, because on your test you're going to be answering free response. So it's all up to you to figure that out without getting this clue right here. So you can do that just by drawing it. So here is triangle. Let's go put in the numbers they've given you. They've given you B is equal to 8. They've given you C is equal to 10. And A you don't have. And they've given you B is equal to 30. So what you have here is side. These are two sides, but the angle is not included. So this is side, non-included angle. And anytime you have that arrangement, you have to consider which of the three cases is it. This is an ambiguous case, and you need to figure out which of the possibilities it is. Okay, so you're always going to start these off because you only have one angle. You can't jump into 180 minus the angles to find missing angles. You have to start off with law of sines just to find the angles. Okay, so notice that you have one complete pair here, the 30 and its partner 8. That's going to make up one of the fractions. And then you're being prompted into a second pair that is semi-complete. You have the 10, but not the angle that goes across from it. So I'm going to be looking for angle C. Just move this over a tad bit. So it's going to be sine of angle C. I'm putting angles at the tops because whatever you're looking for, if it's an angle, put angles at the top. If it's sides, put sides at the top. And then its partner would be that 10. Then I'm going to set up another fraction, and that fraction will be composed of the 30 and the 8. So it'll be sine of 30, we're doing angles at the top, and 8. Okay, then we're going to cross multiply to isolate C. So just swing that 10 right up here. And go ahead and pop that in your calculator. This won't be here anymore. So it'll be sine of angle C is equal to this times 10, sine of 30 times 10 divided by 8. So sine of 30 times 10 divided by 8. I don't know if I even had that on. I didn't. Sine of 30 times 10 divided by 8. And that gets you 0.625. Okay. So now if you want to get an angle, you have to turn this into an inverse statement, which just means you're switching these two. So inverse, as you switch those two items, 0.625 will come right up against the trig function, the inverse trig function, and angle C will jump over and take its place. Okay, so now we're going to put into our calculator second inverse sine of 0.625. And that ends up being 38.68. We'll see whether or not they want us to round to 2 decimal places, but I think they do. So yeah. Okay, so angle C approximately 38.68. I only say approximate because we are rounding it off. Okay, so then once you find this very first angle, remember that right at that point you have to consider whether or not there is an alternative angle that can be used for angle B. Is that possible? Okay, so you make that consideration by going 180 minus the angle that you found. Right now we think that this is, well, we know that it can be 38.68. We just want to know, can it be something else besides that? We know it can be 38.68. Let's put side A out here. So we just subtract the 38.68. We get 180 minus that 38.68. And we get 141.32. Okay, so what would happen if we put that in place of the 38.68? Instead of the 38.6, if we had the 141 right up there, it would be 141.32 plus 30. That's 171.32. That does not go over the 180 degree limit. So yes, you do have the ability to form a brand new triangle, only replacing the 38.68. Okay, so I'm going to just write a comment about that. That since the 30 that was given plus the alternative that we're considering, putting that 141 right in there for in the location for angle C, would mean that I would have 171.32 degrees in my triangle, which is not greater than 180. Therefore, it works. Therefore, you can create a second triangle. And I'll do that right here, where instead of the 38.68, you have 141.32. Everything else that you were given, put it right back where it was. Okay, you were given 30 for angle B. You were told that side B is 8. And the other thing that you were given to begin the problem was C is equal to 10. The only thing that I have changed in drawing this second triangle is I have replaced the 38.68 with its alternative. So you are in the two triangle case. Two triangles can be produced, and you are going to find any and all answers that go with it. And you're going to answer based on what they're prompting you to do. Now for me, when you're taking a test and it's free response, you will just show that you have found each and every value on both triangles. I won't prompt you into a specific way to list the answers, unless it's multiple choice. And if it is one of the few multiple choice questions on the test, then yes, you will be doing that. Okay, so let's go ahead and complete this first triangle, finding any and all missing values. I'm going to start by finding this third angle now that I know two of them. So first thing I'm going to do to complete these solutions is go 180 minus the 30 minus the 38.68 that I found myself. And that would give me angle A is 150 minus 38.68. And that's 111.32. And I'll just pop that in there in case I decide to use it. You do have that option. Okay, and then I only have side A to find. So if I'm going to find side A, I have to switch over to law of sines and have a fraction that has side A in it. So it's side A with its partner. So I had to put that, I had to find that 111 first, because otherwise I wouldn't have been able to go after side A. 111.32 And then I need one other fraction, and what I'm going to use is the 30 and the 8. So I'm doing sides at the top, so I'll put the 8 at the top and sine of 30 right here. Okay, so in trying to isolate A, I'd be swinging this sine of 111.32 right up here so that A would be isolated and I can approximate it. Okay, so this is what I set up, side A across and divided by its partner, sine of 111.32 degrees, and then I use the 830 pair. Okay, so it's going to be, once I swing this up, I don't know that I have enough room to write it there, so I'll just write it here. So it's 8 times sine of 111.32, then divided by sine of 30, and that'll get us an approximation for A. Okay. Clear. So this is 8 times sine of divided by sine of 30, and that is 14.91. Okay, so let's see how they're prompting us to answer here. It says two triangles are produced, we know that, or the triangle with the smaller angle C, which was this 38.68, because here this angle C was a larger angle, has the C angle being equal to 38.68, and angle A turned out in the triangle where C was the smaller value, 111.32. And then this, if this was called A1 belonging to the triangle with the smaller angle C, then this is the angle A that belongs to the bigger triangle and its side. So I actually found A from the smaller triangle, and that you will have to find all missing values when testing. Okay, so I just want to put that out there. All right, so then completing this one, they're still looking for me to, in the second triangle, which is why they're calling it A sub 2, to find A, and also to find the A value that goes with it. If they're calling this A2, then this is A2. Okay, so angle A, just to distinguish from the second triangle, is 180. Go after them just like you did in this triangle, minus the 30 that you were given, minus the 141.32. So they were calling this A1, even though they didn't ask us for that. So this is going to be 150 minus 141.32. And that is 8.68. And then the side that is across from it in that same triangle, I'd have to move over to lost signs to get that. So that would be A sub 2. Its partner is the 8.68 degree angle. And then I need one other fraction from that triangle, and I'll use the 30 and the 8. So 8 is the side. I have sides at the top, and I'm going to be doing sine of 30 right here. Then you would cross multiply this sine of 8.68 right up to the numerator. And that wouldn't be there anymore. And you just have to, after setting up these two fractions, just put that in the calculator. So 8 times sine of 8.68 over sine of 30. Okay, so pressing this in 8 times sine of 8.68 at the top divided by sine of 30. And that turns out to be 2.41. Okay, so that completes the problem. This is called the two-solution case. A lot of work. Okay, so now we've gone over two of the ambiguous cases associated with side-side angle. Okay, now we come to example 6. It says two sides of an angle are given below. Determine whether given information results in one triangle, two triangles, or no triangle at all. Solve the resulting triangles if possible. Because in the case when it's no triangle at all, you'll go to find that first answer and be shut down right away. So let's just go ahead and draw the information as it's been given. Always start by just creating a triangle where you're labeling the angles A, B, and C. And then you can put the sides on. Side A across from angle A, side B across from angle B, and side C across from angle C. A is 1. They say B is 7. And A is equal to 70 degrees. This is your given information. We're going to go after our next angle, our second angle, by looking at what we're being prompted into doing. You have one complete pair here, the 70 with a side of 1 across from it, and you're being prompted into completing this pair. So we're looking for angle B. So it's sine of angle B across from its partner, which is 7, and then in this other fraction, it's sine of 70, doing angles at the tops, across from its partner, 1. Okay, then we go cross multiplying to isolate this unknown. Whoops, that's a 7. Okay, so that's not there, and it's sine of angle B. Let's get a decimal for this. Sine of 70 times 7. So sine of 70 times 7, and that is 6.557 divided by 1. So sine of 70 times 7. Okay, so I'm just going to use... Now we're not at the last step yet, and that's when you want to hold on. Well, you're actually going to be keeping the entire value that's in your calculator in the window until you're ready for it. So this is just something to write. So now we want to do inverse since we're looking for an angle, and they always require inverses. Just switch these two, the sides that they're on. So it'll be sine of 6.5778, even though that number really goes on in the calculator, will be equal to angle B. I don't know if you remember this from chapter 7, but when calculating the inverse sine of either sine or cosine, this number cannot be bigger than 1. It can't be any smaller than -1 and no bigger than positive, and that's called the domain for the inverse function. So of course, because it's a number that's out of the domain, as soon as you go to do the inverse, it quits on you. So when your calculator quits, that means that this value, angle B, this is just the symbol for angle, is undefined. And if the angle is undefined, that means no triangle exists. Because if one of the angles are missing, you don't have a triangle. Okay, so that's the easiest of the 3 ambiguous cases. I have now demonstrated all 3. In example 4, we had a unique triangle that was created in the ambiguous case side-side angle. In example 5, we had the 2 triangles being produced as a result of the ambiguous case side-side angle. And then finally, we got to the third of the three ambiguous cases in example 6 where no triangle exists. And that's because one of the very first angle that you find is undefined. So that would be choice C, the easiest because the problem shuts down pretty quickly, so you don't have to go and find all the rest of the sides. Okay, now we come to some of the application problems. And in example 7, what you're seeing is, let's take a look at this. Find the length of the span of a proposed ski lift from A, there's point A right there, to B. Okay, that's what you're looking for. So this is going to be the unknown that we're going to be looking for. To find the length of span of a proposed ski lift from A to B, a surveyor measures the angle DAB to be 25 degrees, and they show it to you right there, DAB. Okay, and then walks off a distance of L equal to 1550 feet. All the way from A to C, and measures an angle of ACB to be 15 degrees, and that's also noted for you in the picture. What is the distance from A to B? Okay, so let's see what we have here. First of all, when you're given a triangle on the outside of the triangle, that allows you to find its adjacent partner right next to it, because any angle combined with the angle next to it forms a 180 degree arc. So if you want to find angle BAC, or whatever they called it here, ACB, same, no, let's see, DAB. No, that was this one right here. So DAB is this angle right here. And then you're trying to find its adjacent partner inside the triangle. So when this vertex belongs to more than one angle, you use 3 letters to name it. So very first thing I'm going to do is find BAC. So angle BAC is connected to this 25 degree angle. Together they make up 180 degrees. So if you want to know what that angle is inside the triangle, you just go 180 minus the 25 degrees. And that would be 155 degrees. So we know this as well. Very skinny triangle. Okay, so now what you want to start looking at is whether or not you have enough information to use law of sines, trying to figure out what's across from what. Since it is a very slanted, it's an obtuse triangle. One of the angles is obtuse, greater than 90. And so you got to look at it pretty carefully. But if you're on this side, the side that we're looking for, and you go across to the angle opposite it, that would be the 15 degree angle. So X is paired with the 15 degree angle if you're going to use law of sines. So X paired with the 15 degree angle, of which we are taking the sine, and then we need one other fraction. And if you look at this side, that is 1,550. It would be nice if we knew the angle that was across from it, because we would have a complete pair to use for this fraction, which is very easy to get. Because inside this triangle, we already know 2 angles and therefore can find the third one quite easily. So right now, I am finding angle B. Angle B is 180 minus minus the 15 and minus the 155. So that is equal to 180 minus the 15 minus the 155, and you have 10 degrees for that angle. Okay, so now I can complete this law of sines setup. Okay, I paired the x, side x is across from this 15-degree angle, and the 1550, that side is across from the 10-degree angle. Okay, cross multiply to isolate the unknown x, which would bring this sine of 50 right up into the numerator, sine of 15. Okay, so that's not there anymore. X is by itself, and I just have to pop that into the calculator. So it's 1550 times sine of 15, the numerator value divided by sine of 10. So it's 2,310.24. They're saying round to the 2 decimal places again. So 2,310.24, and the unit in this application problem was feet. Okay, that brings us to example 8. So in example 8, let's make sure we get this on number 2. You know exactly what I did first. These application problems are multi-step problems, and then I did this third. Okay, in example 8, we have an aircraft up in the air, 2 angles, and let's go ahead and see what we can fill in on this diagram so we can figure out what we're looking for, what we already have. So it says an aircraft at point Z is spotted by 2 observers who are standing at the X and the Y location. Those observers are 1,550 feet apart. As the airplane passes over the line joining them, as it passes over this line joining the 2 observers, each observer takes a sighting of the angle of elevation to the plane. Angle of elevation means that from the horizontal you have to look up to see something, and that is called an angle of elevation. They say that that is 20 degrees here for angle A as well as angle B. So you're in an isosceles triangle. I'm talking about the main triangle right here. If 2 angles are equal in a triangle, then the sides across from them are also equal. So if this one comes out to be 5, this one will be 5. If this is 6, this is 6, and so on. Okay, that's an isosceles triangle and the properties of an isosceles triangle. They want to know H, how high up in the air, this being the ground, how high up in the air is the plane. So this is going to take more than one step, multiple steps to get to this answer. First thing I'm going to do is I'm going to work with the main triangle, noting that this is X, this is Y, and this is Z. Taking into consideration that this is 20 degrees, this is 20 degrees, and right now all I'm going to think about, without having all this other junk in the problem, is that I have a side down here of 1,550 feet. I have these 2 20s, and then let's see, what else do I have? Okay, so this is what I'm going to do. The first thing I'm going to do is find angle Z. Okay, so when I go to find angle Z, give me one second. It's going to be 180 minus these 20s. So just taking off 20 times, you can just take out 40. Have to take off 40. Same thing. So you have that this is 140. Okay, now if this is 140, what that allows you to do next is to find, so this was the very first thing that I did. And maybe I should renumber these. Okay, that was the first thing I did, and I happen to be using the main triangle. I am still looking at the main triangle as I consider my next move. And let me move this over a little bit. Okay, so my next move, what I would like to do is find these sides right here. Because if I find these sides, and I can only find these sides as a result of finding this, because I can use law of sines right here and set up 1550 with the 140. And do sides at the top because I want to find additional sides in this triangle. I'm wondering what this is and what this is, because if I knew what those two sides are, this one or this one, it really doesn't matter. You have two right triangles, one that points to the right, one that points to the left. So I'm going to work on this one. As soon as I find this side, I can use SOHCAHTOA to find H, which is ultimately what I want. So right now, I am still working in the big triangle. So I'm doing law of sines. It's this with its partner, the sine of its partner, which is a 140-degree angle. And then I want to find either this side or this side. They're both the same. So it's 20 with this unknown angle, and I'll just call it little x, since this is called angle x. Okay, so let's see. I'm trying to find little x, and I'm doing its partner of 20 degrees, sine of 20 degrees. Okay, so cross multiplying, I want to isolate the x, little side x, so I'm going to take this sine of 20 and swing it right up here as a multiplier. That will be multiplied by 1550. So x is sine of 20 times 1550. That's my numerator value, and then divided by sine of 140. And I get 824.7378, although I'm going to keep this entire value in the window. Okay, whenever you have a multi-step problem, you are not to round off to the designated place of 2 decimals until the very last step. In the meantime, you are to hold on to everything that's in your calculator window. So I'll just write that to have something to write. Okay, so now we know that this is approximately 824.7378, even though I'm going to be using the actual value in the calculator window. And I can now finally, in step 3, I can now move to answering the actual question. How high up in the air is this plane? In other words, what is the height from its position in the air down to the ground? Because now I'm in a triangle where I actually have enough information. As long as you have one angle and one side in a right triangle, I'm over here, you can use SOHCAHTOA. So this is the triangle that I'm using, the one that has the height, the plane. There's no way that I can draw a plane. I'll just draw it like this. It looks like a fish. Okay, so you have that. You know, you can't put anything down here because you don't know how much of the 1550 belongs here and how much belongs there. So then this is what you can do. You can find, let me just get these numbers here. You can find H through SOHCAHTOA. And this is from section 8.1, where you're going to figure out which of the trig functions, should you use in SOHCAHTOA? And I'll write that little memory device in here. Okay, so we're going to go with this right here. This is SOHCAHTOA, which can be used for right triangles only. Okay, so what you should do to figure out whether it's the sine function, the cosine function, or the tan function that's going to be used to find h is just call out what it is that you are going to drag into your formula. There are 3 different formulas suggested here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's all a matter of what you've been given and what you want to solve for. So you have to be standing on this acute angle. You could stand up here, but since this is already given, why not just stand on something that you already have? Now call out the names of the pieces to yourself with respect to where you're standing. With respect to me standing on the 20-degree angle, H is considered opposite to me. And with respect to where I'm standing, actually, doesn't matter where you're standing, this is always considered the hypotenuse. So now all you want to do is go and pick which of these 3 trig formulas incorporates opposite and hypotenuse, and that would be this one right here. So that's what you were doing through all the problems in section 8.1. So it's sine of the angle you're standing on is equal to opposite over hypotenuse, which is what the O and the H means. So it's sine of 20 is equal to opposite, which is called H in this picture, over the hypotenuse, which is 824.7378. And of course it runs on, and we are going to use it in its entirety. Okay, you're trying to solve for h, therefore you have to cross multiply, as you have in every problem in this section. Cross multiply that 824.7378 right up into the numerator. So it's not there anymore. And h is now rounded, so it's an approximate answer. Let me go ahead and put that in my calculator. So, oh darn, I got rid of the exact version of that, so I'm going to have to get it back. Sorry about that. All right, let me just grab that back again. Just don't clear it when you're on the last step. So it would be, I got that by going 1550 times sine of 20 divided by sine of 140. Okay, there it is again. Okay, so now in my last step, I'm going to go that 824 number times sine of 20. And that gives me 282.08. Now you can round to 2 decimal places. So 282.08, the unit in this problem is feet. Okay, so 3 steps. I worked in the main triangle XYZ when I was doing steps 1 and 2. And then I switched over to the right triangle that you see pointing to the right here, although this is a duplicate of it. And I used SOHCAHTOA in order to find the height that the plane was up in the air. Okay, moving to example 9. Okay, so in example 9, it says a famous leaning tower was originally 180.5 feet high at a distance of 121 feet from the base of the tower. So this is the base of the tower right here, and this is 121 feet. The angle of elevation, in other words, if you're standing here as an observer and you had to look up to see the top of the tower, there's your angle of elevation, is 60 degrees. Find angle RPQ. Okay, from R to P to Q, that means they're talking about this angle right here. Find RPQ indicated in the figure. Also find the perpendicular. Okay, and I'll draw a picture of that when I get ready for that part. Okay, the perpendicular would just be a segment that comes from, and it even tells you from R to PQ, that you are going to come straight down here at a 90-degree angle. That's what a perpendicular is. It goes from a vertex in a triangle to the opposite side, hitting that opposite side at 90 degrees. So ultimately, we're going to be looking for that also. Right now, let's just see if we can find angle RPQ. Okay, so in step 1, I think the first thing that I'm going to do is, let me just take a look at this for a second, is I'm going to find angle R. And that's because in this triangle, once again, let's go over law of sines. Notice that you have a complete pair right here. You have a side of 180.5 and the angle across from it. So that's one complete pair that you're going to be using in your law of sines setup. And then I have a semi-complete pair. I have 121 and I don't have the angle across from it. Now, even though this is not the angle that they've asked me for, it enables me to get RPQ, to get angle P in my very next move. But first, I need to get angle R because it's the only way that I can go to initiate the problem. Okay, so I'm going to do 121. I am looking for angles, so I'm going to put my angle information at the top. Right now, I'm looking for angle R. So it's sine of angle R. You can either put that little angle symbol or not. Just putting a capital letter means it's an angle. So it's sine of angle R. Its partner is 121. I'm doing sides at the bottoms, angles at the top. One more fraction, I'll use my complete pair, the 60-degree angle with the 180.5. So it's sine of the 60-degree angle, and then 180.5 feet at the bottom. And if I want to isolate this unknown, sine of angle R, I need to swing that 121 right up into the numerator. So that sine of angle R is isolated. Okay, I'm going to pop that in the calculator. Sine of 60 times 121. Okay, sine of 60 times 121 is 104, and I need to divide by 180.5. And that is 0.5805, but it runs on and on and on. So since I am not at the end of this problem, not at the end of the answer that I'm looking for right now, remember I'm looking for this angle right here at P, and I'm not there yet, so I'm going to hold on to all of this. I'll just write that this came out to be 0.5805, even though it's a run-on, and you know that in order to find an angle, you need to do the inverse. I guess I can finish that here. Let me use up the space that I still have. Okay, so I'm going to go inverse, continuing with this. Inverse of 0.5805 is equal to that angle R. All I'm doing is switching these two, as I've done in several problems. This value comes up against the sine function, but now it's in its inverse form, and the R pops out here. Okay, so let's see, what does this turn out to be? I still have that entire 0.5805 number in there, so I'm going to do second inverse, dump in the answer, and I will get 35.48. So they say for this answer right here that they really want this angle, so I'm still not at the end, so I am not going to be getting rid of any of these values. going to indicate here that this runs on and actually use it in that form in my next step. So this was step 1. And for me to answer this first question, find RPQ, now I'm able to do that. So here I am doing step 2. For step 2, if I know that this angle right up here is approximately 35.489 degrees, but actually it runs on, and I want to find the third and remaining angle, then I can do what we've done in many problems. Angle RPQ, that's this angle right here, is equal to 180 minus 60 minus 35.489, but actually using the run-on version of that. Okay, so here's that value. All right, so it's 180. Let's see, minus second answer. So I'm subtracting that 35.489 run-on, and I'm also subtracting the 60, and that gives me 84.5. Now I can round it to the indicated decimal place in the instructions. So round the answer to 1 decimal place, that's 84.5. Okay, so I have one of the answers. Now I have to concentrate on the second question that they've asked me, which is, what is the length of this perpendicular? I'm going to call it H, the height of the triangle. That's what a perpendicular allows you to find. And I'm going to remember that in this triangle, I have just found this 84.5 degree angle. So if I just concentrate on the right triangle that I have going here, really what I'm concentrating on for this second answer is this piece that I'm looking for, the perpendicular. It formed this little right triangle over on the left side of the main triangle, of which, let's see, we have a hypotenuse of 180.5, and I know that's the hypotenuse because it's across from the right angle. And then we also have this angle of 84.5. That's that angle right in there. And all you need to know if you're going to use SOHCAHTOA, see, many of these problems will start off with other laws that allow you to find missing pieces, like law of sines is what we're concentrating on in this section. And then you finish the problem with things you learned earlier, such as right triangles, which has been the main emphasis of this class. And if you have one angle and one side, you can use SOHCAHTOA. You just have to, have a knowledge, which is what you were practicing in section 8.1, of how to choose which of these 3 formulas is appropriate based on what you have. So you always have to be standing here on the acute angle. Call out what this is called, opposite. This is hypotenuse. So if you're going to drag hypotenuse and opposite into your problem, you're using sine. So it's sine of 84.5, and this is the third step of the problem, is equal to opposite over hypotenuse. Just like this formula says, sine of the angle is equal to opposite over hypotenuse. So written more detailed, it's going to be sine of 84.5. Opposite is the H, and the hypotenuse is the 180.5 feet. Okay, so if you want to isolate for H, this says you've done in all the problems in this section, you're going to cross multiply. So this 180.5 feet will come right up here and get multiplied by sine of 84.5 degrees. So it is no longer here. So we are about to approximate H. Okay, just pop this in the calculator. So 180.5 times sine of 84.5, and that gives you 179.67. So we have answered the second question as well. What is the length of the perpendicular? The perpendicular distance from R to PQ, which is this H I just found. Okay, so 179.67 feet. Okay, so that completes that three-part problem, all three steps absolutely necessary. Okay, moving to the problem 10. And that's the last problem. Okay, so in problem 10, it talks about an awning that's being attached to a sliding glass door, which is mounted on a wall. So that wall comes down to the ground, meeting it at a 90-degree angle. But the awning has an angle between it and the sliding glass door of 50 degrees. The purpose of the awning is to prevent sunlight from entering the house when the angle of elevation is more than 70 degrees. So at 70 degrees or higher, it is going to protect from the sun based on the arrangement of the angles. See the figure, find the length L. Okay, so we're looking for this right here. Okay, and then let's see how many steps we're going to have to do. I think first I might complete the kind of angles that we have inside of the triangle. Namely, again, we are started with an angle that is exterior to the main triangle. And anytime you're exterior to the main triangle, you can use it to find angles inside the triangle. Now, it turns out that this angle right here stops at a segment. Whoops, I just messed up my camera. There we go. This angle right here stops at a segment that is perpendicular. So if this meets the ground at a 90-degree angle, then there's a 90-degree angle right here. Well, that 90-degree angle is composed partly of this 70 and partly of the angle that's inside the triangle. So together, these two make a 90-degree angle. So the first thing I'm going to do is find this angle. I'm just going to go for step 1, 90 degrees minus the 70 that's on the outside of the triangle gives you this 20-degree angle that's on the inside of the triangle. You want information associated with the actual triangle, not on the outside of it. Okay, the other thing that this allows, the minute that you find that 20-degree angle, is that you can find this angle. So this angle would be equal to 180. So this will be step 2. 180 minus the 50 and minus the 20. Okay, so that's going to be equal to 130. 130 minus 20 is 110. So this angle is 110 degrees. So now you have all three angles inside your triangle, and you can go about the business of finding. Now we absolutely needed all these things, because the 110, which I found only because I had this 20 first, so they weren't giving me the capability to find anything other than the 20-degree angle first. That was the easiest route to go, and then because of the 20, I found the 110, and now I have a complete pair, which you need for law of sines. That's how you can tell that you can go on with law of sines. So I'm going to pair the 110, taking the sine of it with the 88, and then I compare this 20 with the value that I'm actually looking for, which is L. So for step 3, Now I can use law of sines, and I'm going to do the side I'm looking for paired with the angle that's across from it, which is a 20-degree angle. Then I'm going to do the 110 and the 88. I'm doing sides at the top. L represents the length of a side. So I'm going to use the length of this sliding glass door, 88. And that's paired with the angle across from it, which is the 110. Okay, isolating for L. I swing the sign of 20 right up here into the numerator so that it's no longer there. So L is approximately 88 times sine of 20 divided by sine of 110. Times sine of 20 divided by sine of 110. And that turns out to be 32.0. Let me bring from my desk. So 32.0. The unit that we're using here is inches. Okay, that completes section 8.2, Law of Sines.